Alright, so let's have a short conversation about hemoglobin. Hemoglobin is our oxygen carrying molecule that delivers oxygen from the lungs to the tissue. Now, when hemoglobin binds oxygen, it actually changes the shape of the whole protein. So here's just a demonstration of that change. When it's in the deoxygenated state, it's called the T state. Deoxy equals T for tense. And oxygenated is the R state for relaxed. So you can see that even though it's just the binding of an oxygen, we're seeing a major shift in the shape of the protein between the deoxy and oxygenated states. So the reason for that change in the shape of the protein is represented here. Basically, the heme group that's found within hemoglobin has an iron in it. And when there is no oxygen, it kind of forms a domed or pyramid shape. When the oxygen binds to the iron, it tugs on the iron, and in doing so, flattens this shape of the heme. So instead of it being a pyramid, it's totally flat. And when doing that, it tugs on this histidine. Now, this histidine up here is connected to an alpha helix that's connected to the rest of a subunit of the protein. And each subunit is connected to two other subunits. So say we're looking at the binding of oxygen to this subunit here. Well, these two are connected. And so by changing the shape of one subunit, it kind of disrupts the binding of these two subunits. They're kind of wondering, well, okay, that's different. And what actually winds up happening is it makes it easier for these two subunits to bind up oxygen, making it easier for this last subunit to bind up oxygen. This phenomenon is called cooperativity. And what cooperativity means is that at these low levels of oxygen, hemoglobin is not bound to oxygen. It's harder for the oxygen to be bound. And after that first oxygen binds, so you see there's kind of this lag in the amount of oxygen available to the ability for it to bind. But once that first oxygen binds, we have a rapid increase in these other oxygens binding until we have a completely filled hemoglobin molecule where all four oxygens are bound to the hemoglobin. So because of the change in shape as the oxygen binds right here at the heme group, it causes a change in the shape of one subunit, making it much easier for the other subunits to be able to bind to oxygen. So that's what cooperativity is. That's what causes the major difference in shape between the oxygenated and deoxygenated hemoglobins. And the other major difference between oxygenated and deoxygenated hemoglobin is a color change. That heme group being bound to oxygen causes a major red, beautiful, bright color. When the oxygen is not bound to the heme group, that heme group is not going to cause a bright, beautiful red color. And really does make a major difference in the color of the blood. So just to kind of look at hemoglobin one last time, the oxygenated and deoxygenated states do change the shape of the entire molecule.